Hello, this is Dr. Hine and welcome to the Math Bunker. Today we're asked to find the length of each arc and round your answer to the nearest tenth. First we're going to talk about what exactly is arc length. So let's say that we have a circle and we know what a circumference of a circle is. The circumference of a circle is the distance around any circle. One way to find the circumference of a circle is if we knew what the radius was, and the radius is a line from the center of the circle to the edge of the circumference. We call this the radius. And the formula to find the circumference of the circle, so the circumference of the circle equals 2 pi times the radius. 2 pi the radius, or 2 times 3.14 times from whatever the radius is, will give us the distance around the circle. So when we're talking about arc length, we're talking about any part of the circumference or any part of the length of the circumference, where the circumference of the circle is 360 degrees all around the circle. The circumference, we're talking about just part of the circumference. So if we was to travel 360 degrees around the circle, and we'll say the circle, the length, the circumference, we could say maybe it's 40, 50 feet. The arc length will only be part of it. So we're only taking a segment of the circumference. So let's create an arc length problem. And so I'm going to draw another circle. And I'm going to find the arc length for part of this circle. So let's say I want to find the segment shaded in blue, and we'll call this arc length AB. And let's say that we have a radius from the center of the circle to B. We'll say it's 17 feet. So we'll say 17 feet. That will be our radius. Now, if it's 17 feet from the center to the circumference where B is located, it'll also be 17 feet from the center to where A is located. And we'll say our theta are degrees of this angle, angle AB. Let's say our degrees is 60 degrees. So we have a little angle inside the arc length into the two radius, the B to the center, A to the center, and we'll say it's 60 degrees. And we're asked to find the arc length from A. How long is it from A to B? Okay. So we're going to use an arc length formula to solve this question. I want to know what's the distance between A and B if the radius is 17 feet and there's 60 degrees, if there was an angle between the two radiuses and the arc length. So we can use the formula of arc length, which is 2 pi r, and I'm going to multiply that times the theta over 360 degrees. Now 360 represents the distance around the circle. Okay, since we're using only part of it, it's a proportion. So 360, and the AB will be, I'll use the theta, the degrees on the theta. The degrees, the theta would be the degree on the inside, which is 60 degrees. Then we have the formula for the circle, which is 2 times pi times the radius. That's the formula for the distance around the circle. So if I take that portion, and compare it with 2 pi r, I'll have the distance between A and B. And this is how it works. I'll substitute the theta for 60 degrees. Now it's 2 pi r times 60 over 360. Since the radius is 17 feet, I'll replace the r with 17. I'll also replace the pi symbol. I'm going to use 3.14. So now I have 2 times 3.14 times 17. And I'm going to multiply that with 60 over 360. When I multiply it out, I get 17.79333333. I'm going to get rid of some of these numbers because remember in the instructions it said find the length of each arc and then round your answers to the nearest tenth. And so I'm going to round this to the nearest tenths. So starting from the decimal, the number that's in the tenth spot is the 7. Now I'm going to look to the number in the hundredth spot next to it. If it's 5 or greater, I'm going to add 1 to the 7. If it's 4 or lower, I'm just going to leave it alone. In either case, I'm going to drop the rest of these numbers. So notice that it is a 9, which is clearly greater than 5. So I'm going to add 1 to the 7, and so my answer, rounded to the nearest tenths, will be 17.8 feet. And 17.8 feet will be the distance from A to B, which is also known as my arc length. And again, thank you for joining Dr. Hine in the Math Bunker.